Today, we're going to talk about risk management in the medical device industry, where it is a fundamental practice to ensure the safety, effectiveness, and quality of your device, and that directly impacts patient health and well-being. If you operate within the medical device industry as a manufacturer, software as a medical device developer, you are required to identify, assess, and mitigate, and continuously monitor risks throughout the entire product lifecycle. Last week, I talked about hazard analysis, the must-have risk analysis method based on ISO 14971 for medical device developers. This week, I'm going to focus on FMEA. That is one of the most widely used methodologies in medical device risk management when you have software in the device or you're developing software as a medical device. FMEA stands for Failure Modes and Effects Analysis, and it is a detailed bottom-up risk analysis approach that often complements the hazard analysis approach. FMEA focuses on identifying potential failure modes in components, processes, or software, examining the causes and consequences of these failures. It primarily uses quantitative risk evaluation, employing risk prioritization numbers that assess severity, occurrence, and detectability. FMEA is typically applied during the design and manufacturing phases to target specific risk mitigation actions. While hazard analysis, which I talked about in the last video, is a top-down, system-level approach, identifying and assessing hazardous situation and potential harms across the entire product lifecycle, the FMEA is quantitative, while hazard analysis is typically qualitative. FMEA and hazard analysis are very often used together to ensure that any and all risks have been identified and managed, providing the safety of the device. While hazard analysis gives you the top-down view to the risks, FMEA looks from the bottom up. But let's break FMEA process down into 6 manageable steps so that you can better understand how to conduct the FMEA. So the step 1 is to define the system, subsystem, or component that is under the risk analysis. Clearly establish the scope and consider the entire product lifecycle from design to disposal. Review device specifications, design documents, and applicable regulatory requirements to clarify the intended use, operating environment, and the user profile of your device. Second, form a multidisciplinary team that includes experts from engineering, quality, regulatory affairs, and clinical departments, and then assign responsibilities to each team member to establish a clear communication process that ensures effective collaboration throughout the FMEA risk analysis. Remember, not only assign responsibility to risk owners, but also authority to ensure that the risk owners have the resources to really manage the risks that they own. Step number 3, identify device functions and requirements. In this step, you should break down the medical device into its functions and subfunctions, identify the performance requirements for each of the functions, including regulatory, user, and safety needs. And you can also create functional diagrams to visualize the system and identify any critical or life-supporting functions. Step 4. For every identified function or software component, list all possible failure modes by considering how the function or the component might fail. For that, you can use brainstorming sessions or historical data of similar devices, any complaints that they've had, and of course, test results to ensure no potential failure modes are overlooked. Step 5, identify the effects of each failure mode on the device, on the patient, on the user, or the environment. Evaluate both local effects within the device and broader system-level effects. Identify possible patient or user harms, and also ensure that clinical perspective is applied while doing so. Step 6, identify causes and mechanisms of failure. So in here, you analyze the root causes that could lead to each failure mode to explore potential errors in your design, in software, or in the user handling that might trigger this failure. Step 7, evaluate the risk. Here you assess the risk, assign the scores for severity, occurrence, and if you're using detectability, then also for detectability for each failure mode using the previously defined ranks. And in there, you can calculate the risk prioritization number by applying these 3 scores. And as a result, you have a risk prioritization number or a risk score, which is a numerical value used in failure modes and effects analysis to prioritize risks associated with potential failure modes. If it is on an unacceptable level, you of course need to control your failure mode. So the step 8 is identify risk mitigation actions. You have to propose and document appropriate risk control measures that reduce the likelihood of occurrence or improve the detectability of the failure. Implement these measures through either design modification, normally software updates, and sometimes enhanced instructions for the user. Step 9, you have already a mitigation in place. You now need to reassess the risk post-mitigation. So after you apply the risk controls, you recalculate their RPN, or the risk prioritization number, to verify whether the residual risk falls within acceptable limits as defined in risk management plan. And you can confirm that all mitigations have been properly verified to ensure their effectiveness. And the final step, you need to document and maintain the FMEA. You need to document all the steps, all the findings and decisions in the FMEA worksheet and maintain it as a living document. You can update the FMEA throughout the device lifecycle. That should also reflect the design changes, the manufacturing improvements, and post-market surveillance data. So anything that comes from the users from post-market should also be included there. And you should also report everything that you have documented. For the auditor, you need to have your risk management plan and risk management report in place, and FMEA reports are part of that. I mentioned that last week about hazard analysis, so let's also look into what is the difference between hazard analysis and FMEA. The relationship between the top-down approach of hazard analysis and the bottom-up approach of FMEA is shown in the diagram. The main link between the FMEA and hazard analysis is at the cause level. A certain failure mode has the potential to result in hazardous situation, and the hazard related to this hazardous situation is caused by that failure mode. Let's look into how you can conduct FMEA in Jira with the Risk Manager Plus. I'm going to look at how you can do FMEA inside Jira with the help of Risk Manager Plus app from SoftComply. Risk Manager Plus app is one of the most configurable apps on Jira Cloud today, and it was specifically built for safety-critical product safety and security risk management. Not only does it support hazard analysis, but it also supports FMEA. And we're going to look into how you can do FMEA inside Risk Manager Plus based on an example. So let's say we are developing a smartphone app that records glucose levels, insulin doses, and meal logs for diabetes management. The data that is gathered is synced with cloud storage, and patient data is shared with healthcare providers. We are looking into how software security failures in data handling and access control could compromise not just the functionality of the app, but also the patient confidentiality that could trigger both regulatory and clinical risks. So in step 1, first of all, as always in risk management, you have to start with a risk model. The risk model is actually a risk prioritization number, which is a quantitative risk score-based risk model that usually is based on 3 risk characteristics: severity, probability of occurrence of the risk, and detectability. How easy it is to detect such a failure amount. And based on these, you provide a range of acceptability levels, and that will work as the underlying risk model for your FMEA. In Risk Manager Plus, you have a number of templates for risk models that you can choose from, and you can create one completely from scratch yourself. So once you have your risk model defined and assigned to the project, you can also choose a template from the SoftComply Risk Manager Plus, and one of them would be FMEA. And you can, of course, further customize them as you wish. Step 2 was about assigning risk owners to each of your failure mode. And in here, as we suggested, also provide not just responsibility, but also resources for your risk owners so that they have the ability to really manage these risks. And in here, we have the column for risk owners that will get notification if anything happens to the risk. Risk owners here are users or roles inside Jira that can then track the risk items in real time. But to go back to the beginning, step 3 was to describe the models and functions of your medical device that we are analyzing the failures of. And in here, we have each software item that we want to analyze. And all those software items here are about the glucose monitoring smartphone app that records glucose level, insulin doses, and meal logs. And in another Jira project, you can document the software requirements for this device and link them to the software items inside your FMEA, ensuring the full traceability between product requirements and risk items. Next, we can identify the failure modes. And examples of failure modes for the glucose monitoring app that we looked at would be the misconfiguration of permission management. The results of a permission error could be that a user or caregiver might get unintentional access to multiple patients' data. We also have the encryption failure that may result in a data breach while the unencrypted glucose logs or treatment history is being transmitted. And we could also have a lack of audit logs that will prevent detecting sensitive data breach by third-party integrations, for example. Now we have to understand also what is the effect of each failure mode on the system itself. So what would happen if these failure modes are realized to the rest of the system? The system exposes data beyond authorized user scope, as the users get access to more data than they should. The fact that the system does not record or retain access and activity logs is another effect on the system. And the fact that the system stores or transmits data in decrypted form be yet another effect on the system. Now, what would be the root causes that lead to each failure mode? And here we have to document these as well. And the examples in our particularly described failure modes would be weak authentication authorization control, inadequate encryption of data, and lack of activity logging. After we have described and documented the software item, the failure mode, the effect on the system, and the underlying root cause why this failure mode might be realized, we have to also assess severity, the occurrence of the failure mode, and the detectability of failure mode. And this we do based on the previously defined risk model. Each of these 3 characteristics will have 5 levels, and then we can pick from the severity, probability level, and detectability level from. And based on these, automatically we'll have the risk prioritization number calculated, and we can see the acceptability level of the risk class. FMEA is a quantifiable risk assessment approach where we determine the risk prioritization number or the risk score based on the severity, probability, and detectability. If the risk prioritization number is on an unacceptable level, we will have to put in place mitigation actions. And in the Risk Manager Plus spreadsheet view, you can describe the mitigation action in text, and you can also link the mitigation actions from the other Jira project if there are software requirements. Based on our example, we can have the following risk mitigation actions where we regularly review and test access rights so that we ensure that each rule has the correct permissions. We also ensure that logs are regularly documented and stored, and regularly review these logs so that no suspicious activity is taken place. And finally, we have the dedicated encryption key management system in place, securely managing encryption keys for the encrypted data. We also can link the mitigation actions with the software requirements, and we can test these software requirements to make sure that the mitigation actions are lowering risk as expected. As the step number 9, we have to do a residual risk assessment. So we're assessing the risk again to make sure that the probability and detectability have been lowered as a result of post-mitigation action. And hopefully we can see that the failure modes have been lowered to an acceptable level in the end. The final step is to make sure that the traceability is documented. And in here we can see that in the Risk Manager Plus risk table view, the last column is traceability, the full traceability between the failure mode and the risk mitigation actions and the tests and verification actions. Everything in safety-critical risk management has to be documented. We do risk management plans and risk management reports to find a risk management file, and FMEA is part of that. And inside Jira, we can export them in PDF, we can export them in CSV, but you can also have them in Jira dashboard and in Confluence. A lot of companies who are using Jira are also using Confluence, and they have amazing integration between them, which allows you to do risk management reports and plans inside Confluence. SoftComply Risk Manager Plus has a free extension to Confluence for reporting risk manager for Confluence app, and we will look into how you can report your risks there. Once you have completed your FMEA inside Jira, you can bring the risk reports also to Confluence. And in here, you can see the same FMEA risk tab inside Confluence that we looked at before. And you can also bring your risk models here. In here, you have the initial risk prioritization number for the FMEA risk analysis that we did. And in here, you have the residual risk prioritization number that we had. So we can see that initially, when we assessed the failure mode, we had 1 high level failure mode and 4 medium, and they have all now been lowered to the acceptable level. You can, of course, do PDFs and Jira dashboard, but when you keep all your risk management file inside Confluence, it is most convenient to bring your risk reports also to Confluence using the SoftComply Risk Manager for Confluence, a free extension to our Risk Manager apps on Jira. where you can build your risk reports with macros on Confluence pages. That was all about the FMEA. Thank you for watching and good luck with your risk management.